So the video compositor is basically a language-agnostic tool that allows you to do live video composing. So what is live video composing? You have two parts. First is video composing, and it's pretty much putting multiple videos with some cool effects like grids or like transitions, and we'll show you in a minute how it looks like. But the second part is live part, and it's the tricky part because you have very limited time to do that, from 10 seconds like in HLS to 50 milliseconds in live sources like video conferencing. So what were the key challenges that we had to deal with? First one was that raw video is really, really large. And if you want to do some of the composing, you firstly have to decode the video that you receive, then perform some transformations on them, and then encode it and send it back. Because if you want to receive video in raw format, it's basically too big. Copying it would kill your machine. So also, CPU decoding and encoding costs a lot. Actually, currently, it's most of our computing cost is the encoding. So we wanted to choose technology that in the future would allow us to move that part to the GPU side, and we could send our H.264 streams or any other format to the GPU, decode it there, perform any operations, encode it back, and send back to the CPU the H.264 format or any lighter format than the raw video. Because if you want to send it to the GPU, it's also really, really slow. So how we went about it? So we started with, whenever every multimedia project starts, with FFmpeg. And FFmpeg is a great tool for performing a lot of operations, encoding, decoding, and all that stuff. But it has really limited options when it comes to the composing part. You can do basic stuff like V-stacks, H-stacks, stacking videos in the grid, or overlaying one over the other. But as soon as you start doing really complex stuff like transitions and so on, it stops being a good abstraction over that. So with that, well, just use a browser. And here comes the tricky part. Because if you want to use a browser, you can either send header strings encoded and handle everything by the browser, but then you don't have any control over the enqueuing process of the frames. And if you don't have the control over the enqueuing of the frames, then you lose a lot of on synchronization of those strings. You can't tune those algorithms to your use case. So also the other option is to decode it firstly, enqueue those frames and send them decoded to the Chrome. But then it's you have to copy the memory and you lose a lot of computing power. So we started researching graphical APIs. First one was OpenGL, and GL stands for good luck. It's been quite long with us, but it has really bad developer experience. It lacks many safety features, but it works almost everywhere. It's well-developed ecosystem. You can easily find web developer, any game dev developers out there willing to come to your project if they don't have to work 12 hours a day. And it's basically a decent abstraction for graphical rendering, but we couldn't find a way to decode the video on the GPU with OpenGL. And there comes a Vulkan. So OpenGL was the first thing that Cron's group produced, and the second was Vulkan. And this slide explains the complexity of the Vulkan. Safe to say, we spent like few weeks to just render a single triangle, and it was like over 2,000 lines of code. So we figured out that even though Vulkan can give us a lot of decoding and coding part, and because it already has implemented features for it, It's probably too complex for our project. We are not building a video game after all, yet. So we search further, and we find WebGPU. And WebGPU is another standard that replaces WebGL, and it's still in progress, like many Google stuff things. It's relatively new ecosystem. It has great implementation, WGPU, the REST implementation, that is cross-platform, so you can basically write your code once and then run it on multiple backends. So like on Linux devices with AMD and NVIDIA cards, also you can run it on Mac devices and so on. It has pretty good documentation, but it lacks a lot of things in ecosystem, like previewing how your shaders would look like and stuff like that. And WebGPU gave us the second option to decode video using and decode and encode video using Vulkan, because in the future, because under the hood, it actually on some platforms uses Vulkan and Vulkan buffers, so we could use Vulkan for decoding and coding and use WebGPU for all other stuff. So we use it in our own app, like you've seen before. So how it works like? So basically, VideoCompositor is really related to Membrane and how it processes the video. So you have input streams that are basically videos received over the RTP streams, over the RTP streams. You have some transition nodes that perform some operations, and then the output stream. And this is fairly simple pipeline, but you can get a lot more complex with that. So firstly, I want to show you some quick presentation, how live demo, if you say, how it could work like. So this is simple video room, like video conferencing app. The video will start appearing in a moment. You basically have multiple videos streamed to the compositor. It composes it into a simple grid, adds some text, stuff like that, and send it back. And you can change the way how your streams can look like. Okay. We have also an option to write your own shaders. So shader is basically a code executed on GPU to customize VideoCompositor to your business use case. And here is the example of simple shader written like this. It's basically two streams streamed to the compositor. We have some overlaying them. We are overlaying them and performing some simple operation on one of them with custom shader that basically merges, makes some part of it invisible. And as I said, it's language agnostic, so you can basically, because you send stream through RTP, and the definition of what VideoCompositor should perform via HTTP. Therefore, you can use it in any language you like. And so here we see the same stuff in Rust. Okay. And the last example, it's the web. We talked before about porting the browser. We actually did something like this, because we made embeddings for Chrome engine in Rust to be able to basically embed your videos into any website you want. But it has some downsides, because you have to copy memory between CPU and GPU. Therefore, it's hard to scale that. It should appear in a minute. But you can perform any CSS operation you would like on live videos. So other stuff that you can do is like text rendering, adding images, some basic transformations like corners routing, gridding, and so on are already there. For others, you can write your own code to do that. I encourage you to check out the repo. We have a wiki and examples out there. And see you on workshops tomorrow, where I hope we will teach you a little bit how rendering works. You can write there your own shaders and basically play with it a little bit. Thank you.
Thank you very much. All right, so now a round of questions. Is there anyone who'd like to ask something, Wojtek?
Or is Big Bang Bunny video?
So you said you use WGPU and you use also the browser. So I can choose whether to use one or the other?
OK, so from the user perspective, you don't see how it's implemented underneath. So basically, you don't need to worry about the shader stuff, the GPU stuff, if you just want to merge a couple of videos, right? This was one of the goals of the tool, creating the tool to abstract it from the users. So in the pipeline, you have multiple nodes. And some of those nodes perform operations on the GPU, like the shaders. You can remove green screens and stuff like that. And we have special component in that special type of node in that pipeline, which is web renderer. And you can use it for rendering web stuff, but it has to copy memory from the GPU to the CPU, send it to the share the memory with Chrome Engine, renders it with Chrome Engine, and upload it back to GPU. So it's not the best solution for scaling, but you can easily develop well-looking app quite quickly, because you can use already the abstraction that you know from creating websites and stuff like this.